not too long ago, artificial intelligence was pretty much pure science fiction, right? Something you'd see in the movies. But now, well, now it's this invisible force that's shaping our entire world, running in the background of almost everything we do. So what is it, really? Let's pull back the curtain and actually figure it out. It all really boils down to this one single fascinating question. Can a machine truly think? I mean, really think like we do. This is the fundamental challenge, the big idea that has driven AI development from the very beginning. And as you're about to see, the answer is way more complex than you might imagine. So let's do a quick rewind. Where did this all begin? Well, the term artificial intelligence was actually coined way back at a conference in 1956. From that single moment, an entire field was born, and it's grown exponentially to the point where today it's just woven into the very fabric of our lives. And here it is, the original definition from the guy who coined the term, John McCarthy. The goal was, simple on the surface, but incredibly profound, to build machines that could do things that normally require human intelligence. We're talking about stuff like seeing, making decisions, or even just understanding what we're saying. The dream was to get machines to think and act a little more like us. Okay, now here's where a lot of people get tripped up. Is AI the same thing as machine learning? Nope, not quite. Think of it like this. Artificial intelligence is the big destination, right? The grand vision of creating these intelligent machines. Machine learning, well, that's the vehicle. It's the primary tool we use to actually get there. It's the engine that drives pretty much all of modern AI. So then what in the world is machine learning? Well, instead of a programmer sitting down and writing millions of lines of rigid step-by-step rules, we do something different. We just feed a machine massive, and I mean massive, amounts of data and basically let it learn on its own. It's all about training it to find hidden patterns and make smart predictions, all without us having to hold its hand every step of the way. But how does a machine actually learn? That's the real question, isn't it? It turns out there are three main ways, three core styles, and each one has a totally unique approach to figuring things out. So let's break them down. First up, we've got what's called supervised learning. The easiest way to think about this is like a student learning math with a teacher. You give the machine a bunch of problems, that's the labeled data, but you also give it the correct answers, like an answer key. The machine just studies all those examples to figure out the rules so that later it can solve similar problems all by itself. Next, we have the total opposite, unsupervised learning. This is more like a curious kid who learns without any guidance at all. You just give the machine this huge, messy jumble of data with no labels, no answers, nothing. Its job is to just dive in, look for patterns all on its own, and start grouping similar things together into clusters. It has to discover the secret structure by itself. And finally, number 3 is reinforcement learning. And this one is so cool. It's exactly how a baby learns to walk. You have an agent, that's our AI, and you place it in an environment where it learns by doing. It just tries something. If that action gets it closer to its goal, boom, it gets a reward. If it messes up, it gets a penalty. And over thousands or millions of tries, it learns the perfect sequence of actions to get the most rewards. It's all trial and error. And this table just lays it all out so perfectly. Look at that guidance column. That's the key. Supervised learning is totally hands-on, right? There's a teacher with an answer key. But with both unsupervised and reinforcement learning, it's all about letting the machine figure things out for itself, either by finding patterns in a mess of data or through pure trial and error. And this shift from us giving instructions to the machine having autonomy, that is what makes modern AI so incredibly powerful. Okay, so this isn't just some abstract theoretical stuff. These learning styles are the invisible engines powering the technology you literally use every single day. Let's look at a couple of quick examples that you'll definitely recognize. Ever wonder how your Gmail inbox stays so magically clean? Yep, that's AI hard at work. It uses machine learning to scan all your incoming emails. It's been trained on billions of examples, so it's learned to recognize all the classic patterns and keywords from spam. Things like lottery or full refund, and it just automatically yeets them out of your way. Or what about how Netflix just knows what you want to watch next? It's almost creepy, right? Well, that's a perfect example of unsupervised learning. It analyzes what you watch and then groups you into these clusters with millions of other people who have similar tastes. So by seeing what everyone else in your cluster likes, it can make these shockingly accurate predictions for you. So we've seen how AI works, and we've seen where it is today. But honestly, the really exciting part is looking forward. Where is all of this technology headed? And what is the next frontier for intelligence itself? The way people think about the evolution of AI is usually broken down into these three stages. Right now, and this is important, we are firmly in the age of artificial narrow intelligence, or ANI. This is AI that is a genius at one specific thing, like Alexa answering questions. The next step, the holy grail, is artificial general intelligence, AGI, a machine that can reason and learn pretty much anything a human can. We are not there yet. And then way out there is the hypothetical artificial superintelligence, which would surpass us in, well, everything. And this brings us to the final and maybe most important thought. We have become absolute masters at creating this specialized narrow AI. But the leap from narrow to general intelligence, that's not just going to be another upgrade. It will likely be one of the most transformative moments in all of human history. So the real question we have to start asking ourselves is, are we ready for what happens next?